Okay, so welcome to regular chemistry. We're going to start with Unit 1, Matter and Measurement. And this should be a review of material that you learned in Integrated A, which was your Intro to Chemistry class. I would be naive, though, to think that you would remember everything from that course. So we're going to start with learning Target 1, which is that you would be able to produce a definition of chemistry. And chemistry is the study of matter and the transformations it can undergo. A lot of times students think that the transformations that it can undergo are going to be explosive in nature and that we're going to light things on fire and make things go boom, which we will do from time to time. But you really need to understand that it's just the changing of the matter. And one thing you also need to remember is what matter is. Matter is anything that occupies space, or you might remember the definition from a previous physical science course. Matter is anything that has mass and takes up space. All of the matter that's present in the universe is made up of elements, and all of those elements are organized on the periodic table. Here we have a screenshot of the IUPAC periodic table of the elements, and IUPAC stands for the International Union of Pure and Applied Chemistry. They are the alpha and omega of all things chemistry, and they're also in charge of naming the elements. And so if you ever wondered how some of the elements got their name, this is the organization that is in charge of naming them now. Of important note, the last two elements that were named were elements 114, fluorvium, and 116, livermorium, and they were named in the summer of 2012. And now we have a fun little song for you to watch about the elements. Enjoy.
Hydrogen and oxygen and nitrogen and rhenium and nickel, neodymium, neptunium, germanium and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium and lanthanum and osmium and astatine and radium and gold, protactinium and indium and gallium and iodine and thorium and thulium and thallium. There's yttrium, ytterbium, actinium, rubidium and boron, gadolinium, niobium, iridium and strontium and silicon and silver and samarium and bismuth, bromine, lithium, beryllium and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum and plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, so that's a cute little song there. You guys have all those down? Good. Quiz tomorrow. Just kidding. So back to chemistry. Chemistry is a branch of physical science, and so when you think about all things science, we generally divide them into three basic categories: physical sciences, earth and space sciences, and life science. You had a little taste of earth and space science in your integrated A and B courses that you probably took freshman year. The last life science course that you took was biology, unless you're thinking of taking zoology or one of the other life science electives that are offered here. And with physical sciences, we have chemistry, and then we also have physics that's taught next door. And there's, when you get into advanced chemistry, there's quite a bit of overlap between the physics and the chemistry. The scope of chemistry, there are a lot of things that you can do with the knowledge of chemistry. And so here are just some categories of jobs that involve chemistry. Around here, bulk chemical manufacturing is pretty prevalent. We have all of those chemical manufacturing plants in Calvert City. And of course, with fertilizers, if you're in agriculture or you're a farmer, you know how important those are. Petroleum products, of course, we depend very heavily on fuels and oils. And so creating those and making them more efficiently or making them greener, which is a big trend right now, require knowledge of chemistry. Pharmaceuticals, if you've ever gone to the doctor and then picked up a prescription, Afterwards, from the drugstore, you may have looked inside and there was a little pamphlet that had maybe a weird looking molecule in there. That's generally an organic structure that shows, what the medicine is made of. And if you look at anything that you're wearing today, I bet you're probably wearing something that is made with synthetic fibers, nylon, polyester, rayon, or spandex. And so the catchphrase, better living through chemistry, it's certainly true. Think about what your life would be like if we didn't have some of these things. There are lots of careers that you can have in the field of chemistry. Two major ones would be a research chemist or a chemist who works in development, which means, you're developing something new. There are production chemists and technicians. You could be in chemical sales, software engineering, patent law, teaching. An important note about teaching is if you're interested in going into the field of education, you can almost guarantee yourself a job and some pretty good job security if you have a degree in math or science. So keep that in mind if you're interested in education. Another thing to note would be that our UK Paducah campus has a chemical engineering program, which the last time I spoke with their department, they have 100% job placement and average starting salary around $75,000. So keep that in mind as well. Those are good paying jobs. There are lots of job skills for the future that you could apply to any career based on what you've learned in chemistry. And a lot of jobs require that you would be able to think critically, solve problems using math, synthesize new ideas, be creative, make decisions with incomplete information, and be a good communicator. Chemistry will help develop all of those skills in you, and you can, of course, apply those to any career that you might have. Here is a screenshot from the American Chemical Society, or the ACS, using their 2012 data. And in general, all chemists have an average salary of $92,000 a year, which is certainly a pretty high average salary in comparison to other fields. You can see that it's broken down into people with bachelor's, master's, and PhDs. And of course, you can see there's a bit of a discrepancy between male and female chemists, which I'm sure there are reasons for that. And then it's divided into people that work in industry, which means they work for a company, the government, or academia. And academia just means that they're probably working for a university. They may be teaching and doing research part-time. Also, of important note, 90% of chemists are employed full-time, according to their 2012 data. So not only do chemists have generally pretty high average salaries, but they also are employed, which is important in this economy. Two important stories involving chemistry that I'd like to share with you. One of them is involving Corning glass, which is made in Corning, New York. And so NASA had asked Corning if they could develop a material that was clear and could withstand extreme temperatures because they wanted to make these face shields for the astronauts. Well, Corning glass failed at this, but they did succeed at making really good cookware that can withstand extremes in temperature. So if you go home and check your kitchen cabinets, you probably have some Corning ware. It's very durable. And another example would be aluminum mining. Of course, we all have probably had a soda or something in an aluminum can, and we don't usually think too much about the cost of aluminum, but in the 1850s, aluminum was really expensive. It sold for about $500 a pound because of the mining process that it took. A man named Charles Martin Hall developed a method to extract the aluminum from bauxite, and using his method, he was able to take between 4 and 6 pounds of bauxite to make a pound of aluminum, and brought the cost down to 30 cents. So he sort of overnight crashed the market on aluminum. So lots of things that you can do with chemistry, lots of ways that it can be applied, and I hope that you can answer the question Learning Target 1, can you produce a definition of chemistry?